Okay, Math 3, notes. We're going to open to your table of contents and we're going to add in logarithms. This is just the very basic of it. So go to whatever page you are on. So logarithms, we're going to start with a definition. So logs are the inverse functions of exponentials. A log is an exponent. You guys will hear me say that in class a lot to try to make this a little bit easier on you guys to understand that a log is an exponent. So we move from log form to exponential form and back again. So log base b y is equal to x. So if you'll notice that this log is equal to x and x is our exponent. So a log is an exponent. But our base is b, our exponent is here, and then our answer is y. And we've gone over this in class, and it's just, we'll practice this. But basically, I always do this with my kids, is base, exponent, and you guys will watch me make the circles in class, answer. Okay? Base to the exponent to the answer. There are a few rules with logs. The 3 rules are that your base must always be positive. This cannot be a negative number. It can also not be equal to 1, because then that would just be basically doing 1 times 1 times 1 times 1, which doesn't change. Okay? So your base has to be positive but not equal to 1. And your answer is always going to be positive. Because if you think of exponentials, think of the graph of an exponent. It never dips below 0. Okay, so we're going to evaluate. To evaluate these, I normally have students write them in exponential form. So if you were to write this in exponential form, our base would be 3. Our exponent is unknown because we don't have it equal to something. So our base to our exponent, answer. So our base to our unknown is equal to 81. Well, I can rewrite 81 as 3 to the 4th. So it's got to be equal to 4. So 3 to the 4th. So 3 to the 4th is 81. We're making that circle. 3 to the 4th is 81. Okay, on B, we're going to rewrite it. So 5 to the, we don't know what the exponent is, but we know the answer is 1 over 125. 125 is the same as 5 to the 3rd. But since it's a fraction and this is not a fraction, to bring it out of the fraction, that would be the same as 5 to the negative 3. So our exponent would be negative 3. 5 to the negative 3rd is 1 over 125. So 5 to the negative 3rd is 1 over 125. So these ones we would solve. Again, just rewrite it exponentially. So this is a solve for x. So exponentially, this is 4 to the 3rd is equal to x. Base to the exponent to the answer. 4 to the 3rd to x. 4 to the 3rd is 64. Is equal to x. For this one, we have x to the, x to the 2nd. So x squared is equal to 144. So our unknown in this problem is our base. So x to the 2nd is 144. If we square root both sides, we know that x is equal to 12. Okay, and the last problem. We're going to graph y is equal to 4 to the x minus 1 and its inverse. So I'm going to use a t-chart. So I'm going to start at negative 1, 0, 1, and 2. So I'm going to use a calculator. We're going to 4 to the negative 1, which is 0.1. 25. Enter. 1/4 minus 1. Negative 3/4. So negative 3/4. 4 to the 0 is 1. 1 minus 1 is 0. 4 to the first is 4. 4 minus 1 is 3. 4 squared is 16. 16 minus 1 is 15. If I'm going to graph its inverse, if you guys remember, we can just switch the x and the y. So this is going to be negative 3/4, negative 1, 0, 0, 3, 1, 15, 2. So I'm going to graph those points. I'm going to start with the original. So negative 1, negative 3/4, 0, 0, 1, 3, 216 is going to go up really fast. This is going to have an asymptote at negative 1. I'm going to put that in there as a I don't know if you guys can see that, but I kind of just made a highlighted dotted line. So it's going to not touch negative 1, but come so close to it. So there's our original. So now if we're going to do the inverse, I've got negative 3/4, negative 3/4, down negative 1, 0, 0, 3, 1, 215 is going to be way over there. So on this one, our asymptote is actually going to be, if our asymptote for the original is y is equal to negative 1, that's this line right here, y is equal to negative 1, then our asymptote for the inverse is x is equal to negative 1. So that would be this line right here. So that means these red points are going to come very close to, but never actually touch that line. And they are inverse over the line y is equal to x. So to remind you guys, there are reflections over the y is equal to x. You can see it. The best I can draw it. Not the best. So that's the line of symmetry. There are reflections over that. They have here. I wish I had a better highlighter, one that wasn't yellow. But those are the asymptotes. Now, if we wanted to come up with the equation of its inverse, so going forwards, the first thing we did was 4 to the x, and then we subtracted 1. If we're going to do the inverse, the last thing I did is the first thing I'm going to undo. So I'm going to add 1. And then the inverse of 4 to the x is log base 4. So the equation of our inverse would be x plus 1, add 1, and then we're going to log base 4 that. So I'm going to put it in parentheses and put log base 4. That is the equation of the inverse. Okay?